Yeah, good morning students. In this video, I will be discussing on classless IPv4 addresses. So before watching this video, I recommend you to watch my previous video that is IPv4 classful addresses. Okay. So coming back to classless addresses. So we have seen few problems in the IPv4 classful addresses where the host ID and the network ID are fixed. So if you want to start any small organization with only 10 systems, so it is not possible using class C to get 10 IP addresses. So the least class C itself will provide you 2 power 8 systems, means 256 systems you need to buy, which is already fixed. So because of that problem, you can't buy a specific number of systems as per your convenience. So you need to buy whole block, what I meant to say. So in order to overcome that address depletion, also to provide more uh, organizations access to the internet, we are going for classless addressing. Okay, so in this scheme, what happens? There is no classes at all. There is no class A, class B, class C, class D, and class C, which you have seen in our previous video. But the addresses are still granted in blocks. They will give one block, which is in this form, which was already seen in the previous video, like x dot y dot z dot t slash n. So this is what your IP address. One of the block will be given as per your requirement. From that, you can find the starting address, how many addresses you want. All those things can be calculated. So let's see how to calculate the starting address, ending address, and also uh, number of addresses from a given block of address. Okay. So here is an example. Here I am giving a block of address is granted to a small organization. So they are giving one of the address. So among that group of addresses, one of the addresses is this block 205.16.37.39/28. So they are asking just what is the first address, what is the last address, and the number of addresses the service provider has provided. So this is the block. If you observe carefully, the slash n you can see /28. So it is clear that when I say /28, 28 bits are reserved for network ID. So out of 32 bits, so the available host is only 38 minus 28, which is nothing but 4 bits are available, where you can connect up to 16 systems, 2 power 4, what I meant to say. So in those 16 systems, he is telling this is one of the address or one of the IP address. So now we need to find which is the first IP address, which is the last IP address, and how many addresses totally we have. Totally it is clear. 4 means 2 power 4, 16. But among this, which is the first address and which is the last address we need to find. So first, what is the procedure? We need to convert this block of address, IP address, into binary number. So here I have given the binary representation of the given address. That is what the address here 205 is represented in 8 bits. This is what you are 205. This is 16 and this is 37 and this is 39. So as we already know, so how many bits are reserved for these are the 32 bits 8888. Among these 32 bits, 28 bits are reserved for host ID. So the remaining bits is only 4 bits, which is reserved for host ID. 28 bits are reserved for network ID. Sorry. So we are available only with 4 bits. So 2 power 4 is the 16 total number. So among those 4 bits, so which will be the starting address now? So these are the 4 bits among 32. So these are all reserved for host. So the first address will be all zeros only. Yes or no? Out of 32, these 28 bits are reserved for network ID, which we should not touch it. This is for network naming. So only these 4 bits are reserved for host ID. So the first address will be all zeros only. 0000, last 4 bits. So that is what they have written here. The same till here is the network ID till here. Okay. And the last 4 bits have made it as zeros. So that is what your starting address. So that is what I have converted now into decimal. That is, this block is nothing but 205. This is nothing but 16. Same thing. This is nothing but 37. And now it is changed to 00140. zeros. How much it was? 01234. 2 power 4 is, sorry, 01234 2 power 5 is 32. So now this is what your first address. 205.16.37.22. Sorry, 32. So which will be your last address? Last one, that is 1111. So that is what your last system IP address. So what does it mean here? till here it is network ID, no? The first IP address is 0, 0, 0, 0. Your second system IP address will be 0, 0, 0, 1. Your next IP address will be 0, 0, 1, 0. That is what? 0, 1, 2. Next 3, 0, 0, 1, 1. Next 4, 0, 1, 0, 0. Next 5, 0, 1, 0, 1. Like that, if you go on, it will be like till last number 1, 1, 1, 1. That is what your last system. That is nothing but 16th system. Hope you understood. So what will your last IP address now? It's the same thing. Instead of all zeros, I am making all ones. Okay. So that is what your last address. Again convert 205, 16, 37, and this is what your last block, which is nothing but 47. This is what your last address. So the last address in the block can be found by setting the rightmost 32 minus 1 bits to 1s. That is what 32 minus 28. N is here 8. So 4 bits. 4 bits is 1s. So here what we did, so hope you understood now how to find the first address, how to find the last address, and the number of addresses in the block can be found by using the formula 2 power 32 minus n. So as I told you, 2 power 32 minus n. Here n is nothing but the slash n network ID. The n is nothing but 28. So 2 power 32 minus 28, which is nothing but 4. 2 power 4, which is nothing but 16. So the total number of addresses we have is 16. So in this way, by knowing one of the block address, we can easily identify which is the first address, which is the last address, and the total number of addresses in that particular network. Okay, hope you understood. So there is one more way. So one way is just to make the number of bits as zeros, host IDs, and which will be the starting address. If you make all ones, it will be the last address, and total number of addresses at the 2 power n. There is one more technique known as this one. Another way to find the first address, last address, and the number of address is to represent the mask. Already I told what is masking. If you take class full, it is fixed mask. For class A, it is slash. Here mask is nothing but slash n notation only, where n is nothing but number of bits reserved for network ID. So if you take class full, for class A, the number of bits reserved for network ID is 8 bits. So the mask is slash n slash 8. Okay, that is 255.0.0.0. So if for class B it is slash 16, 255.255.0.0. For class C it is slash 24, that is 255.255.255.0. So in this way, there is standard policy, means we have fixed slash n notations in classful, but here in classless there is no such concept. Okay. So the other way I told you can find using the concept of masking. Okay, this is particularly useful when we are writing a program to find these pieces of information. Okay, let's see. I will take the same example, same block of address. What is that? This one, 205.16.37.39/28. So this we need now. This is very important, slash 28. So I have taken the same block. So this is what slash 28. Okay, can be represented as. So this is what the subnet mask I told now. So slash 28, when I say 28 bits are reserved for network ID. So okay, among 32 bits, and 4 bits are reserved for host ID. As I already told you in the previous video, the network IDs are represented using ones and host IDs are represented using zeros. So out of 32 bits, 28 bits are reserved for network ID here as per slash n. So that's what here I have written all 28 bits as ones and remaining 4 bits are zeros. This is what we call as mask for this particular block. So using this mask, you can find the first address, last address, and the number of addresses. Let's see what happens. So the first address can be found by doing ANDing operation, okay, with the given address and with the mask. So this is what the given address. If I am not wrong, if you see the same example, this is what the given address, and this is what the mask. Just now I have seen. If you do the ANDing operation, then surely you will get back your first address. You know already what is ANDing operation. In ANDing, what happens? If you have one of the bit is different, either 10 or 01, the result is 00. If it is either 11 or if even if it is 0 also, it is 0. So if both the bits are 1, the result is 1, otherwise it is 0. That is what the ANDing operation. Okay, just to apply that here, you can see here 1 0 is 1, 1 0 is 1, sorry 0 1 0 is 0. So one of the bit is changing here. Wherever there is 1 1, it is 1, remaining or it is 0. So this is what we call as ANDing operation. Once you do the ANDing operation, you see the first address what you got. It is as same as your previous example where the last 4 bits are zeros. Okay, and remaining everything will be same. If you want, you can check it. The address what you have will be same only here. There is no change. The last 4 bits are changed to 0. These are all same. So these bits are changed to 0. So in this way, just by doing the ANDing operation with the mask and given address, you will get back your first address. So now how to find the last address? So the last address can be found by doing ORing operation, okay, with the given address, okay, with the complement of the mask. Okay, you should do the ORing operation with the given address and the complement of the mask, not with the original mask. Okay. So the result is your answer. See here, this is what your given address, and this is what the complement of the mask. Don't confuse here because previously you can see here. This is 1 1 1 1 1. Complement means you should write zeros all these, and these zeros you should write it as ones. So that's what I have done here. All zeros, and the last one is 1. Then you should do the ORing operation. In ORing operation, what happens? If both bits are same, the result is 1. If it is 0 0, sorry, if it is 0 0, it is 0. If both bits are same, it is 0. Okay. And if one of the bit is 1, it is 1. If it is either 0 1 or 1 0 or 1 1, the result is 1. If both bits are 0, the result is 0. That is what the ANDing operation. Here you can see that 1 1 1. If one of the bit is 1, it is 1 only. And here 1 0 is 1. Same thing. So except wherever there is 0 0, you put 0 0, 0 0 0 and 1 0 1. Like that, just you apply this ORing operation here, then you will get back your last address. You can see the last address here. You can see there is same data as it is, as I told in the previous technique. Same block or same byte, but if it's the last bit, this is also same. If you see here, the last 4 bits, instead of 0 1 1 1, we got all ones. So that's what we got back our last address. Okay. And how to find the number of addresses? That is just can be found by complementing the mask and then interpreting it as a decimal number and adding 1 to it. So this is what your complemented mask, what you have seen in the previous here. Same thing I am taking here, this one I am taking here, and then convert it into decimal form. If you convert, what happens? 0 1 2 3, 2 power 3, okay, plus 2 square plus 2 power 1 plus 2 power 0. How much you will get? 2 to the 4, 4 to the 8 plus 4 plus 2 plus 1. You will get 8, 9, 10, 11, 12, 13, 14, 15. So just add 1 to it. Then you will get back your 16. What you have seen in the previous example, 2 power n, 2 power 4, that is also 16. So this is another way of getting the first address, middle address, the last address and the number of addresses. So whatever the technique you apply, so the result will be same. So hope you enjoyed the video. Thanks for watching and subscribe my YouTube channel for more videos. Bye.